Now we are going to train the network, and in order to do the training of the network, we need to first define a loss function. The loss in here is quite simple. It's just we have the difference between the predicted value, so y predict, and the actual value, and we return the mean square error, torch.mean. Of course, you can do it other way, but it's very simple, kind of this way. Minus y, everything going to be squared, and of course you will calculate the mean of it. So mean squared error. So shift enter, we define the loss, a bit some space, and then we define the optimizer. Optimizer equals torch.optim. We're gonna use the simple atom and the model parameters, and learning rate, of course, is we define it as we want, but 0, 1 it seems good. And of course, model parameters, what we are optimizing is the model parameters, and in order to get the least mean square error, and this is the optimizer. After that, what we have to do is the actual training process. So we start by process. We start by training or by putting a place to actually save the losses we have, to monitor the training itself or the training progress in range of epochs. But we need to define also epochs to be 2000 steps. And then what we need to do is we have the total loss equals 0, and for for the u not sequence, or the u patch and x patch and s patch in train, in the data we want to train data. This is not this one, train data. Model dot, we want to initiate the model train, and optimizer will have 0 grad. We make everything, the gradients is 0. This is before the training process to make the back propagation. Y predicted equals model, and we pass on the u values along with the locations we need to calculate the x patches. And then we need to get the loss equals loss. Of course, this is a function we have, and we pass on the y predicted and the actual y, which is the s patch. This is the actual value. And once we do that, we can record the loss, of course, every epoch. So every epoch we will sum this loss and find the average value of the loss. So loss, or loss dot item, the actual value, loss total equals loss, just a minute, and loss item. Of course, we can just remove this, put Here plus it's more professional looking, but personally I didn't really, but doesn't matter. Backward propagation, we perform a backward propagation based on this loss, not of course the total, this one, and optimizer dot step, we have one step of based on the optimizer, and this is basically the actual training. This is the process in which we are actually updating the network, and like basically these two, and that's pretty much it. And we keep doing these steps until all the epochs are finished. After that, or after like we every epoch will have to compute every patches of the data, and then the total loss we calculate based on total divided by the length of the this one, actually the train data, because how many we have, we calculate the total loss, but how many times we calculate is basically this one. And in order to monitor the training loss, training losses dot append, and then for every epoch we will have this number saved in this training loss list, and at the end we just print things out. If the modulus of 20 every 20 steps equals 0, then print well, we start like to write some text epoch, and the epochs will be, we open, where is it, or actually just write it like this way. Epoch, and I, or divide the total number of epochs, so we know what is the epoch number, and then loss will equal the total loss, this one. And because we keep printing every 20 epochs, we will print this thing, and we can well, we can make it this way. This means 6 decimal places, because it will be something e to the power minus 6. It's not a very important thing. If you like, just do it this way, very simple way, and then just shift enter, and now the loop starts. So now we have we'll start from 0, 2000 steps, and it will continue up to 2000 steps. Of course, now the loss is should be the highest, or most likely the highest. Now just wait a little bit until the first iteration is done, and after that we will close this lecture, and then we will go to the next lecture, in which we are going to see, is it really we built a network that can integrate any function we want, of course taking into consideration that the x is from 0 to 1, because all our data, the x is from 0 to 1. So now the loss is getting lower, and it will continue to get lower as the training progress. So see you next time.